Hello friends. So today we are going to discuss a problem on design against static load. So you know the basic meaning of static load from your earlier lectures that any load that doesn't change with time is called a static load. Okay. So we are going to discuss a problem that is based on the static load, and this problem are: suppose it is given a C frame. A C frame is subjected to a force of 15 kilonewton that is shown in figure. So this is your C frame. A load of 15 kilonewton has been applied at some distance from its frame center. It is made up of grey cast iron and given Fg 300 and factor of safety 2.5. Determine the dimensions of the cross section of the frame. So we need to find the dimensions of cross section of frame. So from this question we can say that. So suppose if we just look at the first of all what we have given, we can write it as factor of safety. Factor of safety is 2.5. Your ultimate tensile strength SUT, that is given 300. Anything written after Fg is for the grey cast iron is its ultimate tensile strength. So it is in megapascal. Now your force is given, the force P that is given 15 kilonewton, and you need to find the dimensions. So every dimension is given in form of T, so we need to find T. So these are the things that is given. Now if we just draw the figure again, so this is your original figure. If I just copy paste here again, so you can look this. If we just take this is the cross section. This is the cross section, or this portion of the C frame is in stress position. So we need to decide the dimension so that it can tolerate the 15 kilonewton of force at a distance of 7.5 t from its center. So first transfer this force at this point. Now for that, suppose this is your frame. Okay, let me draw this like it, and if I apply like this 15 kilonewton in top direction and 15 kilonewton in opposite direction. Now if I just want to see this force and this force, suppose this is 15 kilonewton, this force and this force is forming a couple. So if I again write this, so I am taking this this area, suppose this is your area that is under stretch position. So a 15 kilonewton force is in a poor direction, and a couple that is in this direction, okay, that is P into E, and your value is 15 kilonewton into 7.5 T. That is the couple, that is the moment. Now you need to design this element. So this is your cross section. You need to design this element under your both bending and direct axial load. So first of all, what is your sigma axial? That is 15 into 10 raised to the power 3 upon your area of cross section, that is 5t into t. Okay, this is your stress arises due to 15 kilonewton in axial load. Now if we write it, it is 3000 divided by t square. This is one for equation 1. Now applying bending stress, this moment MA will cause a bending stress that is in this at this portion it is tensile, and at this portion it is compressive. So let us suppose at take point A. So bending at A, that is M into Y by I. This is the standard formula. So what is M? 15 into 10 raised to the power 3 into 7.5 t. This is your M, and now it multiplied with Y. What is Y? Your Y value is 2.5 t. That is a half value from the center line. So whole is given 5t. So we can write it 2.5 t divided by I. What is the moment of inertia? The moment of inertia will be 1 by 12 5t whole cube into t. So your sigma bending at A sigma bending at A will be your, if we solve it, simplify it, it will be 27,000 divided by T square. Now at A portion only your axial load is same also. So sigma axial A is also 3000 by T square. So now what we are going to do is add sigma bending at A plus sigma axial at A, and that is equal to sigma allowable, that is SUT divided by your factor of safety. Now your SUT is given 300 and your factor of safety is given 2.5. So this value came in, that is 120. Now sigma bending is given 27,000 divided by T square plus 3000 divided by T square is equal to 120. Now solving the equation, we can get T square is equal to 30,000 divided by 120, and your value for T that is coming is 15.81 mm. Now putting the value of T in the above equation, you can get the dimension. So here I am writing the answer. Answer is 5T is 5 into 15.81 and your T is thickness is 15.81 mm. So this is your dimensions of the cross section.